Hello everyone, I'm Fariha and in this video I'm going to give you a presentation on generation of hydrocarbon in the Bengal Basin. 5 people worked together to create this PowerPoint presentation. Here are the name of team members who worked in this presentation file. First, let's know the basics of petroleum system. The elements of petroleum system are source rock, reservoir rock, migration route, traps and seal and overburden. The processes of petroleum system are generation, migration, accumulation, entrapment and preservation of petroleum. In this picture, you can see some of the factor of petroleum system like porosity, permeability, organic matters, etc. There is the connection between elements and processes. For example, in source rock, petroleum generation took place. Then it follow the migrate route and migration process starts. Then traps and seal cause the entrapment of petroleum. In reservoir rock, petroleum accumulation happen. The migration of petroleum needs to follow the right timing so that it traps below the seal in the reservoir rock after migration. Now let's try to understand how source rock generate hydrocarbon. Source rock undergo thermal maturation. It's a process where heat and pressure transform organic matter into hydrocarbons. This marks the beginning of petroleum journey. Tectonic activities like tectonic forces play a pivotal role in shaping the geological framework of Bengal Basin. The basin is situated within the convergence zone of Indian plate and the Eurasian plate. The ongoing collision between this plate in tectonic activities such as compression, uplift and subsidence creates accommodation space for sediments, setting stage for the accumulation of organic rich source rocks. Then basin geometry. The geometry of basin, including its structural features and sedimentary architecture, influences the distribution of rock with hydrocarbon potential. Structural elements like faults and folds may create traps or migration pathway for hydrocarbon. The basin's overall shape and depth impact the burial history of organic rich sediments, affecting the thermal maturation process that leads the hydrocarbon generation. Sediment supply to the Bengal Basin is also a crucial factor in the formation of reservoir rock and source rock. Rivers draining into the basin transport sediments from the Himalaya and other surrounding areas. The influx of sediments contributes to the formation of potential reservoir rocks such as sandstone as well as source rock like shale or mudstone. The influx of sediments contribute to the formation of potential reservoir rock. The influx of sediments contributes to the formation of potential reservoir rock, for example sandstone, and also source rock like shale or mudstone. The organic content within this source rock is essential for the generation of hydrocarbon. Last, sea level changes. Sea level changes influence the depositional environments within the basin. Fluctuation in sea level result in transgression and regression, causing changes in the sedimentation patterns. During transgression, marine conditions prevail, favoring the deposition of organic rich marine sediments. Regression may expose those sediments to terrestrial conditions that affecting the type and quality of source rock. First of all, source rock are sedimentary rocks that contain a significant amount of organic matter. This organic matter is derived from the remains of marine or terrestrial organisms such as plankton, algae or plant debris. These organic materials accumulate in conditions that favor the preservation, typically in fine-grained sediments like shale or mudstone. Expulsion refers to the release of hydrocarbon from the source rock. This can occur through various mechanisms, including pressure buildup, buoyancy, and the development of fracture or faults. Some expelled hydrocarbons migrate upward and accumulate in reservoir rock, forming economically viable deposits. Other may be lost to the atmosphere or other geological formation. The adequacy of organic matter in source rock for hydrocarbon generation involves the accumulation and preservation of organic material, its transformation through thermal maturation, and the potential expulsion and migration of hydrocarbons. There are three basic parameters of source rock, which are amount of organic matter, types of organic matter, and thermal maturity of organic matter. Now you can see the genome shell of the Oligocene time. Genome shell of the Oligocene time is the source rock of Bengal Basin because of its richness in organic matter and its thermal maturity due to deep burial. Its depth is 6,000 to 8,000 meter, and hydrocarbon kitchen is there. Kushiara Trough, Goyan Trough in the northeastern Sylhet, Hatia Trough in the southeastern coast and offshore are known as hydrocarbon kitchen. In this figure, you can see the anticlinal fold structures forming gas field in Sylhet area. Here, Oligocene boreal is the source rock. In that figure, you can see the gas fields and hydrocarbon generative depression are marked there. We already know one of the source rock of Bengal Basin is Genome shell. So next question, is there any other source rock in the Bengal Basin? Another source rock of Bengal Basin is Surmak group shell, which is Miocene age. This is the second candidate for hydrocarbon generation in Bengal Basin. Surmak group shell of Miocene age does not contain enough organic matter, which is less 0.5% TOC, total organic content. Its thermal maturity is inadequate and its lie above the oil window. Moreover, the lower part of the Surmak group has some organic rich shell. They have entered the oil window and might have generated some gas. It might be the source rock in southern Bangladesh. The amount of organic matter is shown as TOC, which is total organic matter. It's a parameter used in determining the hydrocarbon generation capability of any source rock and the quantity of organic matter. Here you can see the table of TOC, which depict the quality of source rock. For example, if TOC is less than 0.5%, you can say it's a poor source rock. If TOC is between 0.5 to 1, then it's a fair source rock. If it has a 1 to 2% TOC, you can say it's a good source rock. If the TOC of source rock is 2 to 4%, then it's a very good source rock. If its value is more than 4%, it's an excellent source rock. There is also marked the threshold of shale gas and shale oil. The amount of TOC in Genome shell is almost between 1.4% to 2.7%, where the TOC in Bhuvan shell is between almost 0.2% to 0.7%. The amount of TOC in Kopili shell is almost 5%. So we can say Kopili shell is a potential source rock. Now let's discuss the type of organic matter of source rock in the Bengal Basin in details. There are two major groups of organic matter which are saprophilic and humic. Saprophilic is the decomposition products of fat, lipid, organic matters like spores and planktonic algae, where humic derived from terrestrial plant cell mainly composed of lignin and cellulose. Organic matter type in genome shell is mainly humic, which is land derived. It has woody origin and it produces only gas, and no oil is generated in genome shell. Kerogen is naturally occurring solid insoluble organic matter that occurs in source rock. It can yield oil and gas upon heating. There are three kerogen types, type 1, type 2 and type 3. Type 1 is of algae origin. It has high hydrocarbon ratio which is more than 1.5, and it has low oxygen carbon ratio. Type 2 is of phytoplankton and zooplankton. It has relatively high hydrocarbon ratio but low oxygen carbon ratio. Type 3 is of continental plants. It has low hydrocarbon ratio which is less than 1, and type 3 has high oxygen carbon ratio. The kerogen type in Bengal Basin is mostly type 3. Type 1 kerogen is less in Bengal Basin. In this table, you can see the approximate equivalence of various terms used in kerogen description. Here are liptinite, vitrinite, inertinite, and which type are those explained here. There are three zones of hydrocarbon generation, which are diagenesis zone, catagenesis and metagenesis zone. Diagenesis is the earliest stage of thermal alteration, and it occurs relatively shallow in the earth crust. However, the temperature is not high enough for significant hydrocarbon generation. Instead, diagenesis involves processes like compaction and the initial breakdown of complex organic molecules. Catagenesis is the next stage of thermal maturation, occurring at greater depth and higher temperature than diagenesis. Catagenesis represents the stage where significant hydrocarbon generation took place. Metagenesis refers to the final stage of thermal maturation, characterized by even higher temperature and pressures. In this figure, you can see the oil or gas window in first column, then the depth of this zone or oil or gas window in the second column of the table. Then the third column show the temperature of each zone, and then you can see the vitrinite reflection information. After that, you can see the three zone or the three subsurface process which are diagenesis, catagenesis and metagenesis. Now let's point out the characteristic of diagenesis zone, which is lie up to 6 degrees Celsius temperature. Diagenesis zone is thermally immature zone. The organic matter is converted kerogen due to shallow burial and low temperature. There is no significant thermal hydrocarbon generates within this diagenesis zone. Only biogenic gas is produced in that diagenesis zone. Catagenesis zone lie between 60 degree to 200 degrees Celsius temperature. It's a thermally mature zone and it has moderate to deep burial. Oil and gas generate from kerogen within this catagenesis zone. Oil window lie between 60 degree to 160 degree Celsius where intense oil generate, and gas window lie between 100 to 200 degree Celsius where intense gas generate. Next, metagenesis zone, which temperature lie between 200 to 250 degrees Celsius. It's a deep burial zone. Small amount of gas generate in this zone. Mainly methane generate in this zone. No oil and gas below this zone. The formation of graphite structure is observed in this zone. Now you see a flow chart which show the generation of hydrocarbon. For example, the organic matter like lignin, carbohydrates, proteins, lipids are undergone microbial degradation, polymerization, and condensation. Then it converts to fluvic acids, humic acids, humin, amino acids, fatty acids, etc. Then it converted to kerogen. After that, this kerogen undergone thermal degradation and hydrogenation. According to its vitrinite reflection in kerogen, it generate oil or gas within oil or gas window. After that, cracking happen and carbon residue lie within the metagenesis. Let's know the time and temperature relationship in case of generation of hydrocarbon. The transformation of organic matter to petroleum is a function of both of temperature and time. Although general temperature ranges have been mentioned before, the beginning of the oil and gas windows occur at higher temperature in the younger sediments compared to the older ones. Here in this picture you can see the right one, Los Angeles Basin is the younger sediments where where you can see the beginning of oil and gas window occur at higher temperature, but in the left side you can see West Canada older sediments where the beginning of oil and gas window occur at relatively lower temperature than the younger sediments. So what I want to say is that the beginning of oil and gas windows occur at higher temperature in the younger sediments compared to the older sediments. Burial of Jainam shell is 6 to 7 km below the surface. The generation of gas happened in the catagenesis zone at a temperature of more than 150 degrees Celsius. Jainam shell is of tertiary time and being a comparatively younger formation, it took a higher temperature and higher depth more than that required for gas formation to actually generate the gas. Next, let's study the migration and accumulation of hydrocarbon in Bengal Basin. First, let's know the formation of traps. Anticlinal traps formed in Pliocene time. Growth of traps took place due to the tectonic subduction of the Indian plate under the Burmese plate. There are 4 pictures which show the patterns of anticlinal folds in some of the gas field in Bangladesh. In the left upper side figure, which show Fenchu Ganj gas field, it has high amplitude fault with single fold. In the left upper corner, you can see in the Molovi Bazar gas field there are high amplitude fault with multiple folds here. In the left lower side, in the lower left side, you see moderate amplitude fault in Hobigans gas field. In the lower right side, here you can see low amplitude fault in Shahbazpur gas field. Next, reservoir rock, where accumulation of hydrocarbon happens. In case of Bengal Basin, sandstone of Surma group is the reservoir rock, which is Myopliocene age. It has good to excellent porosity, 15 to 20% porosity, and also good to excellent permeability, which is 100 to 400 millidarcy. This reservoir rock has repetitive sand shell alteration that provides good enough reservoir seal combination. Last, let's know the migration process. Their long distance migration process took place as much as 4,000 meter from source rock to reservoir rock. The petroleum migrates here through fault. Repetitive sand shell alteration provides enough reservoir seal combination. The migration and accumulation still continues in geological recent epoch. That's all for today. If this video seems helpful to you, please like and subscribe Earth Detective, and also visit our YouTube channel where we upload lots of videos based on earth science. We also organized the videos in playlist based on topics. Feel free to explore and suggest us what you want to learn from us. You can also check description for links of our social media website for resources, PowerPoint file and further discussion. Thanks for watching.